Okay, so I'm live here with 52 weeks of Swift, and I'm continuing my journey through the language. And right now, I'm getting into the concept of initialization, which is the process of preparing an instance of a class, a structure, or enumeration for use. And this process involves setting an initial value for each stored property on that instance and performing any other setup steps that are required before the instance is ready for use. So this would be really common in GUI development. You would potentially initialize a bunch of state for some aspect of the UI. And this does come in handy because you don't need to write a bunch of extra code. It solves a lot of this initialization process for you. So I'm going to go ahead and get started here and share my screen. And I'm going to start off with sharing this window in the playground. And I can probably change the layout a little bit better here. Yeah, this is a lot better. That was too big. I want that layout. And I think we can just stay right here. This looks good. Okay, so next up, what I'm going to do here is I'm going to start down the road of playing around with some of the initial code here. Now, to set up an initializer, first up, what we would do is put this init method, right? So init, and then we would go through here and do some kind of initialization when I have a new instance of a particular type. Now, let's go ahead and build this out first by building a struct. And this would be a good example. Again, from the Swift programming language guide here, is I build out a struct, which is Fahrenheit. Inside of I have a mutable variable, which is a var, and I create a double, which means I have floating point capability. And then I initialize inside of here the state. So this looks pretty clear. How would I actually use this? If I went through and I made an instance of this struct, and I said Fahrenheit right here, like that. That looks good. And then I want to go ahead and print something out. Let's go ahead and do that. We'll say prints default temp is, and then I would go through here and do some string substitution. So I'll use the fact that this attribute now is basically built on top of the instance, which is pretty cool. And I can say the default temp is temperature, and then I can put in, F here. And let's go ahead and print this out. What do we see? Well, we see that this should be able to run here and then run here. And we see, there we go. The default temperature is 32. So really is handy that you can put this stuff inside, initialize every instance of the object with some set of values. Again, it could be like the UI layout. You want it to be laid out a certain way. It goes in here and does that. Now, another thing we can do as well is we can have default property values. So you can set the initial values of a stored property from within an initializer by assigning an initial value to the property when it's defined. And the way we can do that is basically first doing this. So let's go back here and put this right here. So we say struct var temperature is equal to 32. And we can also do basically the same thing using that method. So how about customizing initialization process? So you can provide initialization parameters as part of an initializer's definition to define the types and names of values that customize the initialization process. So in this particular example, we say the following example defines a structure called Celsius, which stores temperatures exposed in the degrees Celsius. The Celsius structure implements two custom initializers called init from Fahrenheit and init from Kelvin. So let's go ahead and take a look at this, paste this code in, and see what we can find out. So we see a struct Celsius, and then inside I have a mutable variable temperature in Celsius. I then initialize the from Fahrenheit here, And so I go ahead and I do a conversion, and then I initialize a Kelvin, and this is the Celsius temperature is basically Kelvin minus 273. So we do some basic calculations inside of here, and those are included. And then how would I actually use this? Well, let's first initialize it, and then let's define a variable. So we'll say let boiling point of water equal to Celsius, and then we'll call that from Fahrenheit, and then let's go ahead and do that from Fahrenheit, and we'll put in 212.0. Okay, and then what does it get? So we were able to actually set that, and now if I want to print this out, I could just print boiling point of water, and there we go. We see that it's 100 degrees. And then if I want to do the next one, let freezing point of water next, we can do this. We can do Celsius from Kelvin. I'll put in 273.15, and then I'll again go through here and just print this out. Freezing point. We have a mistake here. There we go. Let freezing point of water right here. Okay, we print this out, and we see the freezing point is 0. So you can see how it really helps actually with mathematical calculations as well. So what else can you do? You can do parameter names and argument labels. So just like a function and method parameters, initialization parameters can have both a parameter name for use within the body and an argument label for when using it. So let's go ahead and run some additional code here. So we have a new example, which is a struct that has color. We have let red, green, and blue. So basically make those immutable, but then go ahead and initialize them. And then we also have init white, which is red is equal to white, green is equal to white, blue is equal to white. So basically both of the initializers can be used to create a new color instance by providing named values. So if we go through here and we say this, we say let magenta equal red 1.0, green 0, blue 1, and I can actually print magenta. There we go. And then if I want to do half gray, I could also go through here and do let half gray, and then print half gray. And you can see all of the attributes inside of this, right? So it's able to retain that. So initialize parameters without argument labels as well. Here's another example for us. If you don't want to do an argument label, we can do this: struct Celsius, var temperature in Celsius, init from Kelvin, init here. Let's go ahead and run that. And we can also say let body temperature equals 37. So a lot of neat little tricks here that we can do by using these initialization methods. Body temperature. There we go. So what about optional property types? So if the custom type has a stored property that's logical to have no value because maybe you can't set it during initialization, or because it's allowed to have no value, you can declare the property with an optional type, which is definitely kind of cool. And how would you actually do this? The way that you would do this is properties of optional type are automatically initialized with a value of nil. The following example that we're going to take a look at has a survey question with an optional string property called response. So let's go ahead and take a look at this. If we go through here, we can see the class, which is a survey question. We have a mutable variable text, a mutable variable response. We initialize it, and then we notice here that this is an optional type string here. And then we have a function which actually prints out the text. So let's go ahead and call this. We'll say And here's actually the problem. We'll go let cheese question. Do you like cheese? And then we can do cheese question dot ask, because this instance will automatically inherit this function. So we can do that. We can say cheese question dot ask. And what does it say? Do you like cheese? And then if I want to put a response in here, because we don't have anything there yet, because if I go cheese question dot response, notice that there is actually nothing, because it's an optional type. There's nothing, that's nil, but we can actually specifically set that here. So we can go now set this, and we can do this. We can say cheese question dot response. We can say yes, cheese is excellent in my omelet. In fact, I did this today. I had an omelet cheese, and I can go through here and then do the same thing. In fact, let's just be lazy and print this. And now we can see I've set the response, and there we go. Optional, yes, cheese is excellent in my omelet. You can also assign constant properties during initialization as well. Once a constant property is assigned, it can be modified, which is also kind of nice. And you could also have the concept of a default initializer for any structure or class. And so here's a good example of that. Is that we were going to define a class called shopping list item, which encapsulates the name, quantity, and purchase of things in a list. So let's go ahead and try this out. Let's delete this. Go ahead and do this. So here's a shopping list here. And then if I want to make an item in the list, I would just go through here and make an instance of this. There we go. Item, shopping list item. And then from here, if I wanted to say basically var.quantity, var.quantity, what do we get? We have basically, so we can put this, item.quantity. We should see that this should print out. There we go. You can also do member-wise initialization. You can do initializer delegation. You can do a lot of very sophisticated initialization techniques here. The other thing you can do is you can do class inheritance and initialization as well, which is kind of neat. And you can also do initializer delegation as well. So you can do very sophisticated methods for going through and building things out. And I guess we could take a look at, some of those methods here. But I would say that's probably good enough potentially for what I wanted to play around with. And maybe let's see, is there anything else here? Failable initializers for enumeration properties, propagation of initializers. Yeah, some of this stuff I think is a little fancy for me, and I would potentially not play around with it, other than let's maybe close with this, which is setting a default property value with a closure or function. I do like closures. So here's an example of a closure. All a closure is like a nested function. So we have a class, some class, we do a let, right, sometimes. So this is essentially the pseudocode, right, is that we could actually return back, in fact, the function that's in here, right? So it returns back a copy of itself. So basically a closures is a curly brace followed by an empty pair of parentheses. And so let's go ahead and try this out. If we were going to build out their example, and we say a struct, which is a chessboard, we let the board colors be a Boolean value. We do temporary board bool, var is black, false. and we say, we basically do a little logic, some nested loops here. And then notice that what we do is we return back the bool value right here, based on what happens here. And then we have a function which is square is black at, and this one will return back the board colors, right? And so this is essentially taking out this function and returning it back to us. So how would we actually use this? Well, we would say let board is equal to chessboard right here. And then we could actually print out the board as that square, right? So basically this keeps track of the state. And that's one of the values here of this, is that because we're using this closure, it can understand, essentially what happened in the history, right, in the past here. And that's really one of the values of a closure function. All right, so this is a good place to stop for today, and I will stop sharing my screen. Yeah, so next week we'll cover deinitialization, and deinitialization is something that is called immediately before a class instance is deallocated, right? So if you made an instance and you wanted to set some state, you could also do a deinitialization. So right before the memory is cleaned up with automatic reference counting or arc, you could actually go through and do some other, cleanup actions. Okay, see you all next week.